Now we are going to study chain rule. This is the last lesson before the exam, and here if there is a function inside the function, gx is inside the function here. If there is a function inside the function, then we are applying the chain rule. The derivative of outer function and it's going to be equal to derivative times derivative of the inside the function. It must be. Here, if I give one simple example for that one, here there are two functions. One of the function, let's say x to the power of 50, and out this is the outer function, and the other one inside the function. Here it says that this is the power rule also. To the power of n, if we have, then like we are going to get the power in front of the expression, and we are going to decrease the power. Only the extra part here, derivative of the inside. So if I solve for this one, h derivative x is equal to, h derivative x is going to be equal to, here, 50 times x squared plus x minus 1 to the power of 49 it's going to be. The power was 50, 50 minus 1 is going to be equal to 49. What is the extra part here? Now this is like normal derivative rule. The power comes in front and you're decreasing the power. Here the extra part is derivative of the insider part, x squared plus x minus 1 derivative. Then it's going to be equal to 50 times x squared plus x minus 1 to the power of 49, sorry, times x squared derivative is equal to 2x plus 1, the derivative of x is equal to 1, derivative of 1 is equal to 0, and it is not written, and this is the derivative result it's going to be. If we solve another example, here the power is 2005, so this power is going to come in front. It's going to be like this: f derivative x is equal to 2005 times 3x squared plus 5x to the power of 2004. Yes, now the property for the chain rule, the derivative of insider function, 3x squared plus 5x derivative. What is inside or the power here? Inside of the power, this one. So this one's derivative. Here it's going to be equal to 2005 times 3x squared plus 5x to the power of 2004, and this is going to be derivative of 3x squared is going to be equal to 6x plus 5. The derivative of 5x is equal to 5, going to be okay. Here especially we can use for these kind of questions for the root. Maybe the derivative is going to be difficult, but if you write the mx as a power again here, to the power of x squared plus x minus 1 to the power of 1 over 2. When you say the power is 1 over 2, so I'm going to apply the power rule. M derivative x is equal to 1 over 2 times x squared plus x minus 1 to the power of 1 over 2 minus 1 times x squared plus x minus 1's derivative. The power comes in front, decrease the power, and get the derivative of inner part. M derivative x, then it's equal to 1 over 2 x squared plus x minus 1 to the power of 1 over 2 minus 1 is going to be equal to minus 1 over 2 times 2x plus 1, the derivative of it. Now the power is minus 1 over 2, so you can send this one to the denominator and it will be like this: m derivative x (1 over 2) 1 over x squared plus x minus 1 to the power of 1 over 2 times 2x plus 1 is going to be. Here, if you multiply them, these are going to be here m derivative x is equal to 2x plus 1, 2x plus 1 over 2 times 2 power 1 over 2 means it is the root of square root of 2 is here, square root of x squared plus x minus 1 to the power of 1. 1 is here, 2 is here normally, it's written. Okay, this is the result. Yes, this is the last exercise about our question type. Here 1 over x squared plus 3x, normally x squared plus 3x is at the denominator, and we should apply division rule here. And with division rule also we can solve this question with quotient rule. In the previous lesson we learned, but here also the power minus 1 can be written. Fx is equal to, at the same time, x squared plus 3x to the power of minus 1 can be written. So now the power is minus 1, and I'm going to do the operation with respect to that power. F derivative x is equal to minus 1 times x squared plus 3x to the power of minus 1 times the derivative of inside. Derivative of inside. It's going to be equal to f derivative x is going to be equal to minus x squared plus 3x minus 2 times 2x plus 3 is going to be. Here the power is negative, so we should send the denominator. F derivative x is equal to the derivative of fx is going to be equal to minus here 1 over x squared plus 3x to the power of 2. This power negative, it goes denominator, and it will be like this, 2x plus 3. It's going to be, when you multiply integer by rational number, you know we are multiplying only by the numerator, so the answer is going to be f derivative x is going to be equal to minus 2x plus 3 over x squared plus 3x to the power of 2, it must be.